Welcome, everyone. Thank you for joining today's webinar. My name is Lisa Holmes, and I'm the Marketing Director at Royal Circuit Solutions. Today, we're going to talk about PCB laminates. But before we begin, I wanted to just go over a couple logistical details. You should have a control panel in the upper right-hand corner of your screen. If you have questions during the presentation, please use this panel to type them into the question box, and we'll try to answer them during the webinar, but we'll also have time for questions at the end. We've also provided a worksheet that can be found under the Handouts tab. You can download the worksheet from the control panel and use it to take notes during the presentation. So now I'd like to go ahead and introduce our sponsors and our presenters. Our first presenter is John Lass. He's actually in the corner of the screen there. John is the Vice President of Engineering at Royal Circuit Solutions. He was the original founder of the company and has worked in the PCB industry for more than 20 years. Royal Circuits, it's our pleasure to be hosting today's webinar. Over the last 20 years, we've remained focused on helping engineers with their prototype PCB needs fast, and that's whether it's a simple two-layer board or more complex technology. Our other presenter is Megan Cata. She is a field application engineer at Insulectro. Insulectro, as most of you probably know, is a primary distributor of materials used in PCB fabrication, including ISOLA laminates. Megan works with fabricators and OEMs to choose the correct materials and building blocks for their specific customer projects. So at this point, I'm going to go ahead and turn it over to John and Megan to get us started.
Thanks, Lisa. So we're just going to start here and discuss what a PCB laminate is. Essentially, it's going to be made of these three basic building blocks: the resin and glass and your copper. Now, the more complex boards we're getting, we have to really take into consideration the different glass types, copper types, and resins that we're going to use to build our circuit board. Going on, there's a lot of, you can just go to the next one. Yep. There's a lot of different choices that we know the designers and the OEMs have to make before presenting their design to the PCB fab house. We're going to look at a lot of the properties along with the different suppliers of materials, then even types of copper, flex laminates, prepregs, and lastly, you have to remember all of these are going to affect your speed and signal loss. All right, now I'm going to go through some of our basic properties that we will first be looking at when we talk about different laminates. We have our TG, which is your glass transition temperature, your decomp temperature, the CTE, or your thermal expansion, the dielectric constant, and lastly, the dissipation factor, and how all of these properties can affect your choices in laminate when you go to design the circuit board. All right, so the first one we're going to discuss is our glass transition temperature, which, as many of you know, is when our resin actually changes from a rigid or glass-like state to more of a rubbery part. With the introduction of lead-free assembly, we've really had to increase all of the TGs of the resin types to accommodate the solder that we're using for this. So our minimum for a lead-free is going to be around 170 degrees. When we go and look at our different polyimide materials, they're going to be even much higher than this. All right, nextly, we have our decomposition temperature, which is when the resin starts to thermally degrade. When we look at the different PCB laminates and how we talk about the decomp temperature, is actually when the material loses 5% of its original weight. When we're looking at, again, lead-free boards, the absolute bare minimum for a decomposition temperature is going to be around 325. Many of our FR4 materials are going to be up near 340. Then when we get into the polyimide, we're upwards of 400 degrees, and even further is some of the cap-down materials where our decomp temperature is up near 500 degrees. All right, so now we have the CTE, or our coefficient of thermal expansion. It's basically a percentage of how much the resin is moving in our build. We can look at this, we typically look at this in two different ways. We look at the XY expansion, which will also have the effect of the glass, and then our Z-axis expansion. Now, we need to take into consideration when designing the board that the overall CTE is similar between the components and the XY of the board. The more of a mismatch you get, the more stress that the solder is going to see and a potential for cracking.
So let's touch, yeah, thank you, Megan. Let's touch base on impedance for a second here. As we talked about the different values of the materials, the DK, dielectric constant value, determines a lot about the impedance calculations. Within the same family, for example, 370HR, if you have different cores, they have different ranges of values depending on the construction, also depending on the frequency that you're trying to model to. Next slide. So when we go to create a stack up for impedance values, we have different building blocks that we use. We have the pre-preg and the cores. We also take into consideration the tray sizes, the spacing for differential pairs, and also reference planes for modeling the impedance. We have software that we use to model this impedance. We do a lot of this for designers at pre-layout stage so that they know exactly what traces to route to accomplish their impedance target values. And also we take into consideration you know, whether they're looking for a low loss or very low loss material. There's a large amount of materials that are available to use. You know, we have different tiers, tier 1 through tier 5. You know, we have our standard materials, which have a DK range of around 4. Then we have some mid and lower DK ranges, such as FR4 and some ultra low loss materials. Again, it just depends a lot on what you're trying to accomplish with your impedance values, and different copper constructions as far as different frequencies with the coppers.
All right, so as I had mentioned earlier, we have our 3 basic building blocks: our glass fabric, our resin, and our copper. There's going to be some other decisions you have to make with all 3 of these, and one of the first decisions you can make with the specific glass fabric is whether we want to go with a low DK glass or your standard E-glass. Now, for reference, a standard E-glass is going to have a DK of around 6 to 6.5, and your low DK glass is going to have a DK of around 4.5. Ultimately, our resin and glass together give us our overall DK. So when we're looking to keep our DK of the whole composite down, we need to start looking at the lower DK glasses, which will have an increase in cost. All right, our second decision we make when looking at a stack up is going to be the actual type of fiberglass weave. On the screen in front of you, you can see 4 standard types of weaves. Now, your 106 weave is going to be really good for filling coppers. It's a thinner weave, so you're going to have a thinner thickness between your layers if you're only using 1 or 2 plies. As you go to the right, they increase. So your 1080 is another good weave for filling. And and then you get to your 2113s and even your 7628s, which will not be beneficial to try to fill the heavy copper, but they're very good for maintaining thickness and building a big, thick dielectric between your layers. And they're also very good to maintain that dimensional stability. So this is where you're going to try and work with Royal and other fabricators to determine what the best stack up to use for your particular design is. All right, so we just went through some of the standard glass weaves. The other option we have is a mechanically spread weave. What the mechanically spread weave, and we'll go and see some pictures in a minute, does is it actually spreads the glass fibers. And Lisa, you can actually go to that next one. So you can see the 1067 is going to be similar to your 106. However, it is much more spread. What this helps with is that fiber weave effect, which is essentially your timing skew across the panel. So if you can imagine the signal going across this area, it will be much more uniform versus going back to the open weave. Some people might ask, why wouldn't you use a mechanically spread weave all the time? The issue with the mechanically spread weave is you don't get that resin flow to go and fill copper as good as you would get with an open weave. So when you're going with your stack up, that's one of the items you need to think about. All right.
So let's touch on stack ups again. Here at Royal, we have a dedicated team for just creating stack ups for you at pre-design or at the quoting stage. We take a look at heavy copper planes and different needs, and we can recommend different prepregs, as Megan just talked about. We have different options and choices that we can use to come up with the best stable stack up. There's other properties. We go to the next slide. There's a lot of properties we can take into consideration. We talked about the DK values for impedance. You have dissipation factor, moisture absorption. If it's a UL rating that's necessary, we have vast options there. Go to the next slide. We have a large selection of vendors that we can work with to get material. Although we are mainly an ISOLA material-based company, we have a lot of other selections we can go to for, like Rogers for hybrid builds for RF applications. We're able to get materials on a very quick basis for quick turns. We have a very large inventory internally, which allows us to be ready for the quick turns without any delay. And we have quite a bit of rare materials in stock, such as heavy copper, very thin laminates, and different types of high-speed materials available.
All right, so now we're going to be looking at a couple of our main resin types. We have our regular multifunctional epoxy, which is going to be your 370HR. It's standard PCB material. It's been used for a very long time. It's very easy to process. Then we can go to our polyimide materials, which are a little bit more difficult to process, but have a much higher TG. It's typically used in your military and aerospace subsets for boards. Then we go to even our PPO and PPE blends. These are also a thermoset. They have the ability to be lower loss and lower decay. The processing can get a little trickier for some of the fab houses, but these are going to be your materials you want to use for the high-speed digital and RF applications. Lastly, we also have the PTFE or Teflon-based materials. Now note that these are thermoplastic materials, so in order for them to be properly used in a circuit board application, they need to have a very high melt point, which increases that lamination temperature, which may be difficult for processing. All right. These are kind of, as John had touched upon before, some of our divisions and how you would describe what kind of dielectric, what kind of resin you want to look for. We've already discussed the E-glass versus the low decay glass, and you can see here how that does affect your decay. If you're using a standard resin and an E-glass, you're going to be around 4.0 and a little bit higher. When we go to the lower resins with that still standard E-glass, you still are around 3.5. And then when you go to the Teflon and low decay glass, that's when you really start to get below that 3.0, and your dissipation factor is much lower at a 002.
All right, well, let's talk about FR4 material. FR4 material is, it's basically a range or family of materials. It's the most widely used material in the industry. At Royal, we use 370HR as our base material for all multilayers. It's high temperature, lead-free. Even if you have a low temperature requirement, we still build everything on the high temperature 370HR. And again, with the RoHS being a requirement nowadays, we've decided just to go with all high temperature. Again, for inventory purposes, we only have to stock the higher temperature material. We have quite a, like I said, already touched on, a huge inventory of material that we do stock for FR4.
All right, so I just want to address, so the temperatures in this, and actually this slide does show it, are in degrees Celsius. That's typically what we'll look at when we're talking about such high temperatures. And then maybe John can comment on this other one a little bit more. Typically, giving the IBC 4101 splash sheet works well for the fabricators. John, do you want to comment? Is that something that you look for? Is just the splash sheet enough?
Yeah, no, we definitely use the slash sheet, and that gets us at least into the range of what materials are available with that slash sheet number.
Thank you. All right, so now we're looking at some of the higher speed materials, and this picture, this stem right here, is actually a copper foil. It's a lower profile copper foil, which we'll discuss in a little bit more information a little bit later. But we have, when we're looking at these high-speed materials, we want to keep the decay very low, a lot of the times around 3.0 to 3.5, and having the dissipation factor even lower is incredibly important. And then we'll even look at going and using low-profile coppers, which helps to lower loss as well. Some of the ISOLA materials are going to be the Itera MC40. I know 48HR is also a very popular one with Royal. And then going to the next slide, the high speed and the high frequency materials typically go hand in hand. These are going to be a lot of your RF design. Your high frequency materials, again, are going to have the lowest and the most consistent decay. One of the ISOLA materials, Astra, has a 3.0 decay across all of their materials, so it helps take away some of the other imbalances that we talk about when we look at the resin and glass styles. And the other benefit of some of these, we're going to start looking at doing hybrid builds, as Don had mentioned earlier, and that way you can use a FR4 material such as the 370HR and build with the higher frequency, higher speed materials on the outside of your package to keep the overall cost down, but still maintain those frequencies and speeds that you need for your end application. All right, so the next thing, our last building block, is going to be our copper. Now, when we're going and looking at some of these higher speeds and higher frequencies, it is becoming increasingly important to start looking at the lower profile coppers. As you can see, so in the middle of your screen, you have this equation which shows you almost the depth at which we're going to have the signal travel. And as soon as we get to those higher frequency materials, we really get closer to that surface, and it becomes very important to maintain a lower profile copper. All right. So there are going to be three main copper foil types that can be specified. Your typical board is going to have, an RTF or reverse treat foil. Most all laminates will have this availability. Then we go to the next option is going to be your VLP or very low profile copper. We're very original when trying to name these. It's a pretty standardly available. I know ISOLA has the VLP2, which is going to be the 2 micron copper on a variety of their high-speed digital materials, and that'll come as a standard offering. And then lastly, you have your no profile or almost no profile coppers. These are fantastic when we're looking at those conductor losses. However, we lose adhesion when we're going to these very low profile coppers, and we have to make up with them in other ways, such as adding chemical treatments or even roughing the surface, which gets away from that good conductor loss. John?
Okay, and also I guess we're going to touch base on the polyimide material. The polyimide material is mainly used for high temperature applications, and it has low outgassing properties. It's used a lot in burn-in board applications. And again, from an inventory standpoint, we do stock quite a bit of polyimide material. And here's just an example of some of the sample properties of some of the material that we use. Again, I already mentioned that 370HR is one of our base materials that we use on a daily basis. There's a wide application of products available. FR4HR is another one that is commonly used. We get into also some of the iSpeed and Itera and Astra and Tachyon materials. We do a lot of Rogers hybrid with the 4000 series and 370HR, so those are also available for us from Royal. Let's go into how to specify materials. We touched base on a lot of this already, but you have the IPC slash sheet that you can refer to. That's commonly used a lot in fab drawings where they specify the slash sheet that they're requiring. Also the properties of the material you're looking for with the temperature and the decay values. And then again, just material types. If you already know what material you want to build on, you can specify that in your drawing also. We could also look at the signal loss, whether you're looking what frequency you're trying to look for. We can model to that. We touch base on impedance. As I already mentioned, we have one dedicated engineer that does stack ups all day for engineers. We encourage you to take advantage of that. That's available at no cost, and it's a great tool at your design stage. We work with a lot of heavy copper. Again, we stock quite a bit of that, so that is helpful in a quick turn environment. Any special requirements you have, you just need to share with us, and we're able to work with you to meet those needs. And let's go on to the cost. We've already discussed a lot of different materials available in the industry. As you use your standard materials, which is the 370HR, the costs are quite a bit lower than when you get into the iTerra and iSpeed materials. So there's a big range of materials that are available for your needs. And again, at Royal, we have a huge inventory of a lot of these types of materials. We work with all of them on a daily basis and are available to meet your needs.
Okay, great. I was just passing along some questions there. So at this time, we are going to go ahead and answer any of the questions that we didn't get to. And if you have other questions, please take the time to put them in the question box, and we will spend the next 5 or 10 minutes getting to those. If we don't get to all the questions, then we will personally follow up with each of you and make sure your questions are answered after today's presentation.
All right, so I'm just going to address the polyimide and brittle. Someone asked why we referred to polyimide as a brittle material when it is used in a lot of flexible applications. Your polyimide rigid material, which is what we were touching upon here, is different than your polyimide materials that you're going to be using in the flex. When we're reaching those higher temperatures, it does start to get a little bit more brittle than your typical FR4s.
Okay, and I'll touch base on the question about what impedance software do we use. We use a software called Archeo. It's industry software that's used for modeling impedance, and we find that it's very easy to use and very accurate in modeling impedance.
All right, there was another question about, is there a good resource that you can recommend to provide to engineers to help them better understand IPC 4101?
So well, I do know. Go ahead, John.
No, I was just going to say, I mean, there's an IPC webpage that has all of that information available. Some of it's free of charge and some of it you have to pay for, but there's a wide range of IPC information available on their website.
Yeah, and I'm going to also mention that not only is there information on the IPC website, but they do have a lot of classes that are offered to types of engineering, different engineers that can help really explain what the different flash sheets or the IPC 4101 is, and then even go into some of the other documents that they have. So depending on what your specific needs are, they do offer a range of courses as well.
Okay, great. There's one last question about meeting RoHS and REACH compliance.
Well, we definitely do have RoHS certifications that we can supply with the material. On the REACH compliance, that I think we will have to probably get back on, Lisa.
Okay. Great. Okay. Looks like that are all the questions for now. So thank you, everyone. We really appreciate you being here. As I mentioned before, we will be emailing you a recording of today's presentation, and I'll send the contact information for both today's speakers as well. So, oh, we got one more question here. Hold on just a second. Get that. Oh, hold on here. The question is, where does Royal stand on halogen-free laminate?
Yes, we definitely have a halogen-free material available. I don't know if Megan wants to touch base on what material that is.
So ISOLA has the TerraGreen offering. It is completely halogen-free. It has a lot of the same properties as some of the other high-speed digital materials, but so again, it's the TerraGreen. If you need any information on that, you can send us a note, and I can find the TDS and find the other processing information as well.
Okay, great. Well, thank you again, everybody, for joining us today, and we will see you next time.